We've got a talk called Epidemiology of Software Vulnerabilities, a study of attack surface spread by Kimberly Price and Jay Coons.
All right. Good morning. Good morning. Excellent. No, thank everyone for coming. Thank you. We appreciate it. Early in the morning. Doesn't look like too many of you are hurting from what I can see, although this is a sort of a wide room. But we're very pleased to be here today. Our talk, believe it or not, was sort of researched and conceived even before Heartbleed, right? We're here to talk to you today about the epidemiology of software vulnerabilities and the study of attack spread surface. And I'll let Kimberly at some point here tell you a little bit what epidemiology means if you're not aware of that. But my name's Jake Coons. I'm the CISO and one of the founders for Risk-Based Security. We track vulnerability intelligence and data breach stuff. And Kimberly?
Hi, I'm Kimberly Price, and my background's actually in public health. I studied for public health, got a degree in that, and then decided, hey, I really like computers, and switched tracks. So I'm currently running a red team at Synack as the director of operations. Synack is a pen test firm in Silicon Valley. And epidemiology is simply the study of disease spread. So how do infectious agents spread out and cause diseases like the flu or Ebola or Heartbleed in our case, so.
All right, thank you. All right. So we're going to jump in. We only have a little bit of time here today with you, and we want to cover quite a few things. So first, I think when it comes down to it, security folks don't agree on a lot of things, right? You can ask 10 security folks one question and you're going to get 10 different answers. But I think everyone can agree that businesses everywhere are under pressure to perform more and more for their customers, right? To find more meaning in their data and their big data, right? To create better products and all this sorts of stuff. And it doesn't matter what the industry is, trying to get to the market faster, trying to do better products, et cetera. And so what does that mean? It means that when it comes down to it, most of these products and services have some sort of IT component with it, right? Some sort of IT delivery is required to make this stuff happen. And there just becomes these deadlines that are basically from management or product managers imposed on IT just to do things better, right? And when it comes down to it, you typically hear this jokingly, better, faster, cheaper, right? And most people will sort of laugh at this and say, you can only sort of pick two of these. But the reality is people are demanding, companies are demanding now all three of them, right? They want all of these to be delivered so that these products and services come fast. And typically what ends up happening is organizations are just focusing on these new products, these new features, and when it comes down to it, there's always just something that they're forgetting. And what is it? Here's a little hint. Security is always sort of forgotten in it, right? It's getting faster to market, more features, et cetera, right? And so quickly, I want to talk to you just a little bit more about this better, faster, cheaper.
So there's a concept in project management called the iron triangle. You can have it cheap, you can have it fast, you can have it good. Pick two. And open source software and third-party software is helping us accomplish this central state of nirvana where we can get closer to having all three. It's a opportunity for us to not start everything from the ground up every single time, but to essentially recycle code that has been used in other products, that's been tested and used for many, many years. So third-party code is actually something trying to help us manage the iron triangle, as it were.
So with these pressures, what is it? It's third-party libraries to the rescue, right? And developers, when you speak to them, it's really to speed up the development process, right? Again, we've talked about getting things there faster, but it's also many cases for quality purposes, right? Instead of building something from scratch, right? Why would we develop something in-house from scratch? We can leverage something that's been out there for a while and get better quality out of it. The other thing too, in speaking to a lot of developers, and maybe some developers in the room will nod their heads, when it comes to it, a fair amount of time is, I don't need to worry about security. I use these libraries, right? Why would I need to care about any of the security stuff you're talking about? I just make these calls to these libraries and things just work, and that's why we do that. And then when you dig a little bit deeper, asking questions about what that really means, then you see a lot of developers' eyes sort of open up and then maybe get a little concerned, et cetera, right? All right. So we've set the stage a little bit about what we're talking about. Now we want to talk a little bit about what is the problem. And really the biggest problem right now is this is something that is really hard for organizations to get their arms wrapped around, right? I mean, what is going on here? And that is probably the fundamental problem. So there are so many of you in the room with us today. This is fascinating. We're actually really pleased that you're here, right? Whether it was Heartbleed motivated or not, we'll never know. But lots of companies right now are really struggling with what is this whole library thing. So when you go to look to try to find information about third-party libraries, it's few and far between still, to be quite frank. Secunia put out a study, their vulnerability review of 2014, and one of the things that they said and got a fair amount of press in this space is said third-party programs are responsible for 76% of the vulnerabilities discovered in 50 of the most popular programs in 2013. All right, does everyone know what that means? Or early in the morning, right? So what's interesting is if you, on the surface, you look at this, you sort of think, hey, this is addressing and talking about this third-party library issue that we're talking about. But like most reports that come out, when you examine them and try to figure out what's going on, usually you find quite a few flaws. It's an interesting report, the way that things are counted. But really, the real thing is, even though the statements support what we're talking about here today, this has nothing to do with third-party libraries, right? This is them looking at sort of vulnerabilities and what they'll say is third-party programs, but really what they're saying is non-Microsoft programs. That's what they were tracking, right? So this isn't really helping us so much. So if we take a step back and a little bit of an eye chart, but here's some vulnerability statistics, and we're not going to get in today the merits of counting vulns and why that's good and bad. There's plenty of information on that out there. But just at a high level to talk about orders of magnitudes here, we're still seeing poor code being written, right? I mean, this is just what's going on. And so if you look at sort of the numbers over time, this is from the OSVDB project, you can see that there's still about 10,000 vulnerabilities a year coming out, right? And that doesn't even include sort of tracking issues in the cloud or multi-tenant environments and that sort of stuff, right? So there's a whole slew of vulnerabilities that are not even in these accounts. If you slice it a little bit more with a different sort of eye chart, what this is just trying to show you here is that it's not just sort of the number of vulnerabilities that's alarming, it's also the types of vulnerabilities, right? So you figure, 10 years later from us talking about things like cross-site scripting, SQL injection, that we would maybe have eradicated them by now, right? And that it just sort of isn't the case, right? And you can see here on this sort of line chart here that cross-site scripting still is the most tracked vulnerability, right? So we're not even seeing normal sort of 101 vulnerabilities being squashed out. And then comes Heartbleed, right? And again, most people prior to Heartbleed weren't hearing much about these third-party libraries. We joke that a fancy logo can go a really long way, right? And so data breaches, right? You hear about them all the time on the news, without a doubt, right? Whether it's Target or these new accounts compromised, you're hearing about data breaches all the time. Vulnerabilities, maybe from time to time, but can you think of anything in a long time like Heartbleed that was everywhere, right? The logo and the Heartbleed was all over the media and all over the place. And so it really started bringing people's attention to it. And we believe that when it comes down to it, the reason is that all along, we've trained users that when you're on the internet, it's a very, very scary place, so you have to be careful. But if you're on a website and you see this little lock, you are good. Everything is good, life's good, do whatever. And all of a sudden now we've just crushed them by saying, yeah, you could still see that lock, but you're hosed, right? And that's really what people could understand. And when people can understand things, it becomes more real. And so that, it's interesting because since Heartbleed, Openssl has had several vulnerabilities come out. Some could be argued worse, and you haven't heard a single thing about them. Maybe it's because they didn't have a fancy logo, or maybe it just isn't they couldn't really sort of understand and comprehend what was going on. So what happens, and when people start realizing that everywhere they go there's a problem, people start thinking about things like systemic risk, right? And what's happening with whether it's libraries or the interconnected Internet of Things, everything now has sort of systemic risk with it. Most things have it, right? And we're talking about the interconnected nature of everything that's going out there. And most people, they have a hard time thinking about systemic risk until you see a picture of maybe a hurricane, right? And you realize that one event can cause multiple problems, right? And so we're starting to see things like third-party libraries making some of these awful sort of analogies like the cyber hurricane, right, starting to come a little bit true here. And that one vulnerability can spread across multiple organizations, right? And that's really what's eye-opening. So back to Heartbleed, right? It was a CVSS, if you're into the scoring stuff, 5.0, right? Is that what it was? Not much more than that, but then all of a sudden everyone's looking at it, right? And again, that systemic spread across, what we find is that 100+ vendors were impacted by Heartbleed, right? So we're starting to see one vulnerability in a ton of places. Here's another eye chart of a bunch of vendor names. There's like 68 or 70 of them up there as we started getting tired of typing them in there. That's where we're at. And what really ends up happening is that a lot of people will start thinking about these, open source libraries, third-party libraries, and start saying only companies that are cutting corners or don't care about security, or sort of small startups that can't deal with it are the ones that are using these types of things, right? And you can see if you look even closer, we're not talking about that. We're talking about major organizations, major vendors that are using and are impacted by things like Heartbleed, right? And so there was this huge outcry, right? It's the worst thing ever. It's all over the news. We got to get this fixed. Everyone's rushing to it. Then there's some research done that says 2 months later after Heartbleed, there's still 300,000 servers that are impacted, and we've sort of seen a tail off of people fixing things, right? So now we're sort of accepting, hey, this is tough to deal with. So you start to have to ask the question, right? Efficiency at what cost? And we've already talked about the Iron Triangle and what it can do, but while it may be in sort of Heartbleed, again, one library affecting multiple organizations, what is really eye-opening, if you're actually involved with this, you know this stuff, but if you're not, certain programs or products out on the market can have hundreds of these libraries in there. So we're not just talking about only a few libraries you need to look after, it's quite a bit. And so when you look further, it's a whole lot of sort of monitoring, tracking, patching, fixing that needs to be taken care of. So with that, let's talk a little bit of data.
Thanks, Jake. So we took a look at data. Originally, we had submitted for a 50-minute talk, and we're honored to have been given 25, but we're not going to have time to go over as many libraries as we'd initially planned. Now, we all know some of the big name problematic libraries that have a lot of vulnerabilities, like Java or WebKit. And so we're going to focus on some that maybe are a little less well known. And we're going to look at them in a few ways. We're going to start, of course, from a data-driven concept, which is what's the volume of frequencies over the last 7 years, the frequency of release, and we'll talk a little bit more about why that's important, the average vulnerability severity, as Jake mentioned, Heartbleed, which was incredibly impactful, was really only rated as a CVSS 5.0, and the pervasiveness of the library usage. So we'll start with Openssl because we're all pretty familiar with it. We've talked a little bit about it. They've got 24 releases, 45 vulnerabilities, and an average CVSS score of 5.39 over the last 7 years. So 87% of those vulnerabilities are remote exploitable. And 40% of them have to do with input manipulation. So someone's manipulating the input remotely and resulting in exploitation of a vulnerability. And it's releasing updates 1 to 6 times a year, and that's a pretty wide range. The reason this is important is if you're only updating your libraries with every major release of a product, you're probably missing some important security updates. And so release cadence starts to come into play when you think about what libraries do I want to use as a developer. So this is, as Jake mentioned, used in a lot of places. Let's talk about some of the online stuff. It's used in Gmail. It's used in Tor, which I know folks here tend to really like using. It's used in LastPass. It's used in WordPress, GoDaddy, Box, VMware, Netflix, Tumblr. I kind of got tired pulling down icons, so here's a whole bunch more. It's used in a lot of products everywhere, and all of those products needed to update. So let's talk about FreeType. FreeType has on average 2 releases a year. They've got 50 vulnerabilities in the last 7 years with an average CVSS score of 7.89. FreeType is an interesting one because it's included in WebKit, but it's also used independently. And so what's using FreeType? FreeType is a font parsing engine. So parsing fonts is hard. And so if you can use a library that's been tested and vetted, that helps. And so on the FreeType page, they indicate over 1 billion devices are using FreeType just in these vendors' products. But we dug a little deeper and looked across the internet and saw that it's also used in OS X because it's in WebKit, it's in Firefox, OpenJDK, OpenOffice, StarOffice, Ubuntu, Gentoo, Solaris, you name it. It is in an American Girl video game for children on the PlayStation. It is in a lot of stuff. And okay, so it's font parsing. Well, FreeType CVE 2011-0226 had a CVSS score of 9.3. It was a vulnerability that was used in Jailbreak Me on the iOS. And this vulnerability, if it were only locally exploitable so that the owner of the iPhone could jailbreak their device, would be a terms of use issue. But it wasn't. It was remotely exploitable. And so what happened was there was a problem with the input manipulation, or they were able to manipulate a parameter that allowed the pointer to be misused in the stack, and it gave remote code execution. So now we have a pretty significant problem where people can't use their browser or potentially HTML email or anything that is parsing a font without risking exploitation. Okay, libpng. Okay, libpng is used for graphics rendering, and that is their logo? Okay. Very fancy. Okay, so they have 26 vulnerabilities, 3 releases per year, a little bit more manageable, average CVSS score of 6.8. And you're thinking, okay, you're talking about releases per year, you're talking about how many vulnerabilities. These two things are interrelated. Each development team has to decide for itself, would you rather have several small updates on a regular basis, or would you rather have big updates every now and then? Okay, we got the 10-minute warning. We're going to move a little faster. So we've tracked libpng to over 130 applications, including, we've got Adobe up there, we've got Google up there, we've got Apple up there, we've even got Microsoft up there because it's in Visio and PowerPoint. Why is it used everywhere? Because people want to have compatibility. You don't want to have different applications to open different types of files. And compatibility, ubiquity, universal user experience, all of this requires that we start working with these open source and third-party libraries that are consistent. So countless applications. Last one we're going to run through really quickly is Ffmpeg, and it has only been releasing advisories since 2011, so it's a slightly truncated view. 64 vulnerabilities with 3 releases per year and an average CVSS score of 8.35. This is a lot of fixes when they do release, at least in the first couple of years, as you can see. And this is a complex piece of video processing software that everybody who uses it has to do a little bit of customization to work it into their system. So every time they have an update, it's not just shimming in the new version, it's making it work in your product. So it'll do your video work for you. You might be seeing some of the same logos coming up, and that's because we end up seeing products that are using open source code are using a lot of different libraries, and so they're having to update on a regular basis, again, for multiple things. It's not just, oh, I have to update Openssl a couple times a year. I have to update Openssl and Ffmpeg and libpng, and all of these libraries all release on different cycles. So I'm going to turn it back over to Jake.
So, you know, we're painting sort of a doom and gloom picture that no one's doing anything, but it's not entirely true, right? So there are some things that are currently being done, and people are trying to find some ways to make people accountable and look for better accountability moving forward, right? So there's already some attempts in place. But what always comes up, right away is this sort of open versus closed source debate, right? Like Heartbleed comes out and then it's all of a sudden just don't use open source because open source is awful, right? And what you'll hear people say all the time about open source is that it's actually secure because everyone can look at it, right? And that's so everyone can look at it. They can find bugs easier. It makes it shallow, find these bugs, and that's why it's more secure. But the reality is everyone could look at it, but they don't, right? And so that when it comes down to it, accountability is deferred for the most part. So then, obviously, people will say this means that closed source is more secure, right? Because no one can review it and find these problems easily, and it's supported by enterprises. So clearly, closed source is great code, right? And we've already talked sort of at length showing you some high-level stats on vulnerabilities out there. And the reality is bad code is just that. It's bad code. And it doesn't really matter where it is, open or closed source, and it exists in closed source, right? But it always comes back to show me the money, right? And a lot of people believe that money is the answer, right? And that money is what we need. And so if you look at a lot of these projects that are out there, or if you've ever had the pleasure and displeasure to get involved in some of these open projects, you'll find that they are definitely not funded the way that you would hope they would be, and then the resources and people donating time and volunteering aren't there as well, right? So we've started to see some folks trying to put money into these projects, right? So we've started to see bug bounty programs, right? Bug bounty programs are definitely all the rage. We've seen the Internet Bug Bounty program out there that does focus on things like Openssl and some infrastructure things. And again, it's trying to crowdsource more eyes to look at these pieces of software that are critical for our infrastructure. Also seeing code audit initiatives out there, right? TrueCrypt, Openssl, et cetera. So what are the results, right? We see a crowdfunding thing go up trying to raise $100,000. I think it's stalled out at $7,200, right? So that's where our money's being put. Openssl, the foundation, comes out and basically says, hey, we should have 6 full-time developers, and it shouldn't be on all of you guys. It should be on the big companies that use us. We then have sort of the tech giants, if you will, come together, IBM, Facebook, Intel, Microsoft, Google, et cetera, and say, all right, we'll give you some stuff. We use it. We need to invest in it. And at the end of May, they get 2 full-time developers, right? So that's a start. It's not the 6 that they wanted, but 2's on the right track. And there's also funds now to review and conduct a security audit of Openssl. We're also starting to see people that are saying, you know what, the only way to have quality is to fork the code and own it entirely, right? And so we're seeing things like, Google with Blink from WebKit and BSD with LibreSSL for Openssl, right? And this is also, you're starting to see things like Google coming out with Project Zero, right? Really investigating and looking into the bugs and certain things that we rely on. But as a customer, it's interesting because when you're sitting there trying to figure out what to do with these things, the first time that we see a release of the OpenBSD LibreSSL, you see a report that comes out saying it's very problematic, right? Things are wrong with it. And you see words like catastrophic failure and unsafe for Linux. Okay, well, I thought it was being forked because it's going to be better, and you see this. And then very quickly, the next day afterwards, you see the OpenBSD team go back and say, completely overblown. By the way, we've patched it right away. And it leaves you sort of as a customer trying to figure out, again, what should we be relying on here? What should we be doing? And it makes it hard to figure out what some of those actions may be. So Kimberly is going to talk to you a little bit about actions.
So we're not saying not to use third-party code. It's important, it's necessary. We're simply saying we can't eliminate the risk. How do we manage it? We've got to move forward. So we're all in the echo chamber of security. We know this is a problem. Help educate your development teams on what they're committing to. When they're choosing a library to use, when they're looking at their options, make sure they're aware of the vulnerability trends and that they have a realistic view of how many resources they need to support that, and that they have a clear prioritization model, because you don't want to try to figure out prioritization when something's going very, very badly. Bad decisions are made when people are panicked. And try, if you can, to find areas where you can make design recommendations to them that will minimize their risk. If they can sandbox libraries in a way that minimizes the exploit impact if a vulnerability is found, do it. What does that response process look like? Does it end in denial or panic? No, this is a bad response process. What you really are going to be looking at is when you identify an issue, assess the impact, dev and test the fix, you're going to release it with a CVE, and then you're going to have the post-release communication to your customers. But oh, hey, wait, that vulnerability wasn't in your code. You find out about it when the third-party library releases the vulnerability, and now your development cycle starts. And now you get to start doing the impact assessment and deving your code. And your customers don't even get a chance to patch until much later in the vulnerability lifecycle. So this is why having a really clear incident response process is important if you're using third-party code. Monitor your libraries, know what you're using. If you have no idea what's in your code, your legal team may actually be helpful. They have lists of things for compliance reasons. They should know what you're using. And so that's a starting place. But code like Black Duck, Palamita, that can help you know what's in your code real time. Vendor security testing, don't just test your product, test the libraries that are in it. I mentioned incident response plans. That's what I've been doing for the last 4 years, so I'm going to beat that horse to death. And on the IT side, ask your vendors, hey, I know you use this library and I saw they just had a vulnerability. When are you going to fix it? Push back up the stack, if you're an IT manager, to your products and ask them, hey, when are you going to patch this? What's your release cycle look like? And plan time for your own sustainment. Okay, I got done before the 0 time warning. I think we might have time for one question. One. None? All right. Oh, yes. I couldn't hear it. I'm sorry, I couldn't hear it.
Do you see any movement of people taking, when they build an application, go through a build process, going from third-party source, not just binaries?
The companies that I have worked at in the past have simply been using the third-party libraries.
Just the binaries?
Yeah. Okay. Thank you all very much.